I presume everybody has heard in high school chemistry that the bonds get stronger, the energies always get lower. So as you go along in a reaction, usually the end result has less energy than the beginning. They kind of explain it with things getting better. You know, this is the way things go. And it kind of makes sense to us, but we're never given an explanation, not even at university. So I'm going to look at it here, and the solution is not that straightforward, because biology is what you have to use. So if you think about it, it's just like evolution. Things just get better on the long run. Now, why is that in evolution? In biology, in biological evolution, what happens is there are impacts, and the animal or plant can survive a certain impact or die because of it. So in biology, their ability to survive drives their evolution. So what's with chemistry? It's pretty much the same thing. What you have to see is that molecules are not alone. They are together with other molecules. They are bombarded with other molecules. Might be of the same kind, might be of different kind, that doesn't matter. They are bombarded. There are collisions every time. And these continuous collisions drive a certain selection. Because you see, a collision can hit a molecule and break a certain bond. And when a bond is broken, it's going to be reformed. And that is the start of a reaction. It starts with the breaking of a bond. The energies of the collisions of these molecules are distributed in the Boltzmann distribution. And what that means is that it starts, falls down sharp, and then it levels out. Sharp and down. And what that means is that you have a very large number of little energy collisions and a very small number of high energy collisions. Now, if you think about it, a bond is strong if it can withstand something. The reason why a bond is strong is because it takes more energy to break. So the weak collisions will not break the bonds. The bonds that are easily broken will be broken. You will not see those around. You will only see the strong bonds, and this way collisions drive the bonds to stronger and stronger and stronger. But even the strongest bonds are sometimes broken by a very energetic collision. Collisions can be so powerful that they might cause a nuclear reaction. So if you take a Geiger counter, a nuclear counter of some sort, put it next to a human, and you'll see that couple of seconds it flashes. This also means that a chemical reaction that takes a lot of energy to initiate will happen as well. It will just be slower because the reactions that start are more rare, as it's more rare to find an energetic collision to start it. And the conclusion of all of this is that chemistry is interestingly driven by biology as well as physics. Physics, the Boltzmann distribution, and biology, evolution. Both of these things are necessary. Evolution is easy to understand, but the Boltzmann distribution, that needs quite a lot of physics, quite a lot of philosophy, and possibly even more math. I will do a whole lecture on this, and the whole lecture will be devoted to solving it. But the interesting result that comes out of it is that the sharpness of this exponential curve, the Boltzmann distribution, is related to temperature. It isn't exactly temperature, it is related to temperature. So what happens is that if the temperature is high, you get a larger number of high energy collisions. So the curve kind of levels out. It's a bit like this. But as you go to lower temperatures, the high energy collisions kind of stop and you get a very sharp curve. And that is the reason why at lower temperatures things tend to calm down, stop, reactions are slowing down, etc.